Nowadays, not knowing Git is not an option. It would feel like a total handicap. Conversely, knowing it very well gives you a ton of freedom, feels like a superpower. You can mix and match your commits. You can navigate complex repositories, really know what's going on and understand very complex systems simply by knowing Git. So today we start looking at Git from the ground up. We're going to look at the Git blob. We're going to see what they are, what they're for, and we're going to learn everything there is to know about blobs. So first we look at the theory, and then we look at some real blobs. So let's get started. A Git repository is a very simple thing. It is a directory containing your project files and a .git directory. And this is the repository. And the files that are checked out in your project are the working tree. Let's say that we are starting a project from scratch with a single file, and we initialize it with a git init, and the repository is initially empty. Then we do git add. What happens then? Well, here's the cool part. Git creates a copy of the file, adds a little bit of metadata to it, and saves that into the repository using the checksum as file name. More specifically, it stores it under the objects subdirectory. And that, ladies and gentlemen, is the blob. So every time you git add something, Git calculates the checksum of the content, and if there is no blob with that name yet, Git simply adds a new blob with that checksum as file name. And that is the beautiful thing with checksums. The same content will always yield the same checksum. And even the smallest changes to the content yield wildly different checksums. Using checksum as the name of the blobs makes doing the opposite quite easy. So if you don't have those files anymore and you want to retrieve them, all that you need is to keep a list of their names and their checksums, and Git will readily get them back into your working tree for you. And that's why Git is called a content addressable file system. You get the file not based on its name anymore. You know its content and you know its checksum, so you retrieve it by its checksum. Content addressable file system. But how about we look at them in action? Let's jump into the trusted terminal here and let's start creating a repository and dissecting blobs. Let's go. To create a project, we need a directory first. So let's create a directory with mkdir, and let's say that we're working on our next revolutionary fitness app called Fitter. And then we cd into Fitter. And we initialize the repository with git init. And we received this little warning that the branch should be changed to main because master is not politically correct anymore. So we abide and we do git branch -m main. Okay, good. So now we see that Git has placed a little directory inside our project directory, and the directory is called .git. There it is. And inside this .git directory, we have a whole bunch of things. To get a full picture of it, we can use the tree command. So let's do tree.git, and we get this more nicely represented structure of the .git directory. We're going to get familiar with all of this, but for now, let's focus into the objects subdirectory because that's where our blobs are going to live. So we're going to, from now on, get used to doing tree.git/objects. This is what we're interested in. But instead of creating blobs, doing tree, and seeing them appearing, I've created a little utility here called cmdiff. It is in my GitHub if you're interested, but it's just a hacks for this video, so don't care about that. And then we do the command that we want to track tree.git/objects. Okay? And we can see here that our VS Code now has a diff between the previous version of the command output and the newer version of the command output. Right now, we don't have anything in the directory, so the two versions are the same, left and right. So let's create a new terminal here. And, well, let's start using our Git repository. So let's echo the word hello into a file called file1. The file name doesn't matter for now, but file1 is the best I could come up with for now. I'm the most creative YouTuber on earth. Okay, so now we have a file called file1 in there, and if we cat the content of this file, we see that we have the content hello. Now let's git add file1, and let's see what happens now, right? I told you that that's the moment when things happen. Press enter, and now we see that Git has created something in our .git/objects directory. What is it? So it is a directory called CE, and within the directory there is a file with a very strange name that is the blob. The problem is that it's looking a little bit intimidating for now, so let's become familiar with it so it doesn't intimidate us anymore. Let's try to see what's inside. So let's do the naive thing here and do cat.git/objects/0136 tab complete. Oh, that didn't work, and that was expected. Things are easy, but not this easy. What is skoroch ? We're seeing gibberish there because the content of the file is compressed, and it is compressed with zlib. And to decompress zlib, we use a utility called pigs. You can install it on Linux, you can install it on Mac. I don't know about Windows, who cares? So to use the pigs utility, you simply type pigs. We pass the flags D and C, and then the path to the file, git objects ce. Boom. Now, looks much better. We have the word blob, a space, the number 6, and then hello, which was the content of the original file. Okay, but now this is inside the .git directory. Now the problem is that this is not the entire truth, and that is a big problem for us right now because we're trying to learn everything there is to know about blobs. So this output is hiding some characters from us, and to dissect that completely, we're going to use the Hexdump utility. So let's pipe this to the Hexdump -C for human readable content, and let's see what this gives us. All right, so what are we looking at here? On the left, we have the hexadecimal code of each character that is output. So basically the value of each byte. And on the right here, we have the ASCII representation of those numbers on the left, okay? And then we can see that we have 62 for B, 6C for L, 6F for O, etc. And then there is a dot, and that dot is 00. 00 is the no byte. And in C, well, Git is written in C. In C, the no byte is usually a string terminator or a field separator. It is a special character that's put in there saying, hey, now the metadata is over. From now on, we see the content of the file, okay? And then from that null character, we have the word hello, and then a dot again. And that dot is the character 0A, which is the new line character. And the sneaky echo command that we use to create this file is the one who added this new line to the end of this file. So every blob will follow the same format. It will have the word blob, a white space, and then the size of the file, and then a null character saying that all the metadata is over, and then the full content of our file following that. That's it. That is the blob. So there is one thing missing for us to look at, and that is the file name of this blob, this directory CE013. Let's look at that. That is a checksum, okay? And to calculate the checksum here is very easy. Instead of piping the content of the blob into the Hexdump utility, we simply pipe it into checksum. And there you have it, CE0136. So we see that this CE is actually part of the checksum. So the first two characters of the checksum become the directory where the blob is going to be located, and that's just a bit of an optimization that Git does to not end up with too many files in the same directory. So there you have it. But now we don't need to suffer so much anymore using this pigs utility, pipe to Hexdump, to figure out the content of the blob. We can use proper tools that are provided by Git to inspect blobs if we want, okay? So let's do that. Let's use the git cat file utility provided by Git to inspect blobs. Let's see how it works. So git cat-file is what we need. And then what comes next here is simply the checksum, CE0136. And we don't even need the entire checksum. So we don't need to give the .git/obs, so all that's gone. Just the checksum of the object that you want. And the first flag that we're going to learn here is the -t flag. -t for type, and Git tells us that this is an object of type blob. And the next flag that we're going to learn is -p for print. And here we see just the content of the file. I didn't want to use that from the beginning because this sort of hides some things from the blob. It hides the raw structure of it. Now that we know the raw structure of it, we can choose what we want Git to tell us. So that's it. I think for now we have a very good understanding of what a blob is, what they do, what they're for. But if you have sharp eyes, you realize that we're completely throwing away the file names. The file names are stored nowhere in the objects directory there. So how does Git know about file names? When the git checkout, the file needs to go back into our working tree in the correct place with the correct name. Well, that is the job for trees, and that's what we're going to look at in the next video. So see you there. Hej då!